By the early 1920s, Albert Einstein had become one of the most recognizable scientists on Earth. His theory of relativity had been confirmed through observation, newspapers across the world had written about his ideas, and universities in many countries invited him to speak. But fame did not bring him the quiet life that many people imagine for scientists. Instead, it placed him in the center of a world that was becoming increasingly unstable. Europe was still recovering from the devastation of the First World War. Millions of lives had been lost, entire cities had been damaged, and the social structure of many countries had been shaken. Old empires had collapsed, and new governments struggled to find stability. Many people felt uncertainty about the future. Economic difficulties added to the tension. Inflation and unemployment affected millions of families. In several countries, political groups began promising strong leadership and simple solutions to complex problems. Einstein watched these developments with growing concern. Unlike many intellectuals of his time, he spoke openly about his opposition to war and violence. He believed that scientific knowledge should unite humanity rather than divide it. In his view, scientists had a special responsibility. They were among the few people capable of seeing beyond national borders. Science itself depended on international cooperation. Discoveries made in one country helped scientists everywhere. Einstein believed that if scientists allowed themselves to become tools of political conflict, the consequences could be dangerous. His views made him both admired and criticized. Some people saw him as a moral voice, speaking for peace. Others believed that scientists should avoid political statements and focus only on their research. In a time when national pride and political conflict were intense, Einstein's words sometimes placed him in uncomfortable situations. Yet he continued speaking honestly about what he believed. At the same time, his scientific reputation continued to grow. Einstein traveled frequently during the 1920s, giving lectures in many countries. He visited universities in Europe, the United States, and Asia. Everywhere he went, large audiences gathered to hear him speak. Some came because they were physicists eager to understand relativity. Others came simply out of curiosity. The idea that space could bend and time could change fascinated people, even if the mathematics behind the theory remained difficult to understand. Einstein's speaking style was calm and thoughtful. He did not speak like a dramatic performer. Instead, he explained ideas carefully, often pausing to think before answering questions. His quiet personality made him appear approachable rather than intimidating. Students often felt comfortable asking him difficult questions. Sometimes Einstein used simple images to describe complicated scientific ideas. He explained that space was not empty and rigid, but something flexible that could change shape. Massive objects like stars and planets could bend the structure of space around them. Other objects would then move along the curved paths created by that bending. Although these explanations were simplified, they helped people imagine how gravity might work in Einstein's theory. During these years, Einstein also received many honors. Scientific academies invited him to join their organizations. Universities offered prestigious positions. Governments awarded him medals and recognition for his contributions to science. In 1921, he received one of the most famous prizes in the world, the Nobel Prize in Physics. Interestingly, the prize was not awarded for relativity. At the time, relativity was still considered mathematically difficult, and not yet fully confirmed by enough experiments. Instead, Einstein received the Nobel Prize for his explanation of the photoelectric effect. This discovery showed that light could behave as small packets of energy rather than only as waves. The idea helped lay the foundation for quantum physics, another revolutionary branch of science that would reshape the understanding of matter and energy. Einstein used a large portion of the prize money to support his family. His personal life had become complicated, and financial stability helped reduce some of the pressure he faced. But despite the honors and recognition, Einstein remained focused on scientific questions. He believed that relativity was only one step toward a deeper understanding of the universe. The laws of nature seemed too elegant to exist as separate pieces. Einstein hoped that eventually scientists would discover a unified theory capable of connecting all fundamental forces. Such a theory would explain gravity, electricity, magnetism, and other forces as different aspects of a single underlying structure. This idea fascinated him. For many years he worked on mathematical approaches that might lead to such a theory. But the problem was extremely difficult. Even Einstein, with his extraordinary insight, struggled to find a clear solution. Meanwhile, the political situation in Europe continued to grow more dangerous. During the late 1920s and early 1930s, economic crises created widespread fear and anger. Many people looked for leaders who promised strength and stability. In Germany, a political movement led by Adolf Hitler began gaining power. The Nazi Party used nationalist propaganda and blamed many social problems on minority groups. Their ideology rejected intellectual freedom and promoted strict political control. Einstein, as a Jewish scientist who spoke openly about peace and international cooperation, quickly became a target for extremist groups. Newspapers aligned with nationalist movements attacked him personally. Some critics even tried to discredit his scientific work for political reasons. They described relativity as Jewish science, attempting to turn scientific ideas into political arguments. Einstein understood that the situation was becoming increasingly dangerous. Although he had spent many productive years working in Berlin, he began to realize that Germany was no longer a safe place for him. In 1933, Adolf Hitler became the leader of Germany. Almost immediately, the government began implementing laws that removed Jewish citizens from universities, government positions, and many professions. Einstein was traveling outside Germany at the time. After hearing the news, he made a decision that would change the rest of his life. He would not return. Instead, he accepted an invitation from the United States to join a newly established research institute in Princeton, New Jersey. Leaving Europe was not easy. Einstein had spent many years building his career there. Many of his friends and colleagues still lived in European cities that were becoming increasingly unstable. But he understood that remaining in Germany would place him in serious danger. So he began a new chapter of his life across the Atlantic Ocean. In Princeton, he would continue thinking about the deepest mysteries of the universe. Yet the world he had entered was moving toward another global conflict, and the discoveries of physics would soon become connected to one of the most powerful and dangerous technologies humanity had ever created. When Albert Einstein arrived in the United States in 1933, he hoped that the most dramatic chapters of his life were behind him. Europe had become dangerous, political tensions were rising, and many of his colleagues had already been forced to leave their homes. Princeton, New Jersey, seemed like a peaceful refuge where he could focus on the work that mattered most to him. He joined the Institute for Advanced Study, a place created specifically so that scientists and scholars could think freely without the pressure of teaching large classes or managing university duties. For Einstein, this environment felt almost ideal. His daily life soon settled into a simple routine. In the morning, he would walk slowly through the quiet streets of Princeton toward the Institute. People in the town quickly became familiar with the famous scientist, who often walked without socks and whose hair seemed to grow in every direction. Despite his worldwide fame, he behaved like an ordinary resident of the small American town. He enjoyed simple conversations with neighbors, took long walks to think about difficult problems, and sometimes rode a bicycle through the streets. Many people in Princeton later remembered seeing Einstein walking quietly with papers under his arm, completely absorbed in his thoughts. At the Institute, he spent hours working on mathematical problems. Einstein's great scientific dream during these years was to find what he called a unified field theory. He believed that the forces of nature should not exist as separate pieces. Instead, gravity, electricity, and magnetism might all be connected through deeper laws of physics. If such a theory could be discovered, it might reveal a hidden unity behind the universe. Day after day, Einstein worked through complex equations, trying to discover this connection. But while his life in Princeton appeared peaceful, events unfolding in Europe were becoming increasingly alarming. The Nazi government in Germany had already begun transforming the country into a dictatorship. Jewish citizens were removed from universities and public positions. Books written by Jewish authors were publicly burned. Many scientists who had once worked at German universities were forced to flee. Several of these scientists eventually arrived in the United States. Among them were physicists who had been studying the structure of atoms. In 1938, an important discovery was made in Germany by Otto Hahn and Fritz Strassmann. They found that when uranium atoms were bombarded with certain particles, the nucleus of the atom could split into two smaller parts. This process became known as nuclear fission. At first, the discovery seemed like a purely scientific result. But physicists quickly realized something remarkable about the reaction. When the nucleus of an atom splits, it releases an enormous amount of energy. Even more important, the reaction can produce additional particles that may cause other atoms to split as well. If this process continues repeatedly, it creates what scientists call a chain reaction. Such a reaction could release huge amounts of energy in a very short time. Some scientists immediately understood the terrifying implication. If a controlled chain reaction could be built inside a device, it might produce an explosion far more powerful than any weapon that had ever existed. For scientists who had escaped Nazi Germany, this possibility was deeply disturbing. They knew that Germany had many talented physicists. If the Nazi government began researching nuclear weapons, the consequences could be catastrophic. One physicist who worried intensely about this possibility was Leo Szilard. Szilard had once lived in Berlin, where he had known Einstein personally. Like many other Jewish scientists, he had fled Europe when the Nazi government came to power. In the United States, he began thinking about how to warn political leaders about the potential danger of nuclear weapons. But there was a problem. Most government officials knew very little about nuclear physics. The idea that atomic reactions could produce powerful weapons sounded almost like science fiction. Szilard realized that the warning needed a voice powerful enough to attract attention. And there was only one scientist whose name was recognized around the world: Albert Einstein. In the summer of 1939, Szilard traveled to visit Einstein at a small house where the physicist was spending time near the ocean. During their meeting, Szilard carefully explained the recent discoveries in nuclear physics and the possibility of chain reactions. Einstein listened thoughtfully. Although he had not been directly involved in nuclear research, he immediately understood the significance of what Szilard described. The idea that such power might be used by a dangerous government alarmed him. Together, the two scientists discussed what could be done. Eventually, they agreed that the United States government should be informed about the situation. Szilard drafted a letter explaining the scientific discoveries and their possible military implications. Einstein agreed to sign the document. The letter was addressed to the President of the United States, Franklin D. Roosevelt. In clear but careful language, the message explained that recent discoveries suggested it might be possible to create extremely powerful bombs using nuclear reactions. It warned that Germany might already be investigating such weapons. Einstein urged the American government to support scientific research into nuclear energy and to remain aware of developments in Germany. The letter was sent in August 1939. Only a few weeks later, Germany invaded Poland. The Second World War had begun. At first, the American government responded cautiously to Einstein's warning. Roosevelt created a small committee to examine the scientific information and determine whether the threat was real. As more scientists became involved in the discussion, it became clear that nuclear weapons might indeed be possible. Eventually, the United States launched a massive research effort known as the Manhattan Project. Thousands of scientists, engineers, and workers were brought together to solve the complex technical problems involved in building an atomic bomb. The project became one of the largest scientific and engineering efforts in history. Interestingly, Einstein himself did not work on the Manhattan Project. Despite his scientific fame, the U.S. government considered him a possible security risk because of his outspoken political views and his support for international cooperation. Instead, other physicists led the research that eventually produced the first atomic bombs. In July 1945, the first successful nuclear test took place in the desert of New Mexico. Only weeks later, atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki. The explosions destroyed large parts of both cities and caused enormous loss of life. When Einstein learned about the destruction, he felt deep sorrow. Although he had signed the letter warning about nuclear weapons, he had never worked on building them. His intention had been to prevent Nazi Germany from developing such a weapon first. But Germany had already been defeated by the time the bombs were used. Einstein later reflected on this moment with regret. He once said that if he had known Germany would not succeed in building an atomic bomb, he might never have supported the letter. From that point forward, he devoted much of his energy to speaking about the dangers of nuclear weapons. He believed that humanity had entered a new era in which scientific discoveries could threaten the survival of civilization itself. Einstein hoped that nations would learn to cooperate and control these powerful technologies wisely. He often warned that the greatest challenge facing humanity was not scientific knowledge, but human wisdom. After the Second World War ended, Albert Einstein entered the final stage of his life. By this time, he had already become one of the most famous scientists in the world. His theories had transformed physics, his name was recognized across continents, and his face had become a symbol of intelligence and curiosity. Yet Einstein himself never behaved like someone who believed he had solved the universe. In his mind, the greatest questions were still waiting to be answered. He continued living in Princeton, New Jersey, where he worked at the Institute for Advanced Study. The institute had been created so that scientists and scholars could think freely without the pressure of teaching large classes or managing university duties. For Einstein, this environment felt almost perfect. His days followed a simple and familiar rhythm. In the morning, he would walk slowly through the quiet streets of Princeton toward his office. Local residents became used to seeing the famous physicist walking calmly with papers under his arm. His hair, which seemed to grow in every direction, made him instantly recognizable. Despite his global fame, Einstein lived modestly. He preferred comfortable clothes, enjoyed playing the violin in the evenings, and valued quiet conversations with friends more than public ceremonies. Inside his office, he spent hours working on mathematics. The scientific goal that occupied him during these years was the search for what he called a unified field theory. Einstein believed that the forces of nature should not exist as completely separate phenomena. Gravity, electricity, and magnetism might all be connected by deeper principles that scientists had not yet discovered. If those principles could be found, they might reveal a hidden unity behind the entire universe. For many years, Einstein worked patiently on complex equations that might describe such a theory. But while he continued searching for this deeper understanding, physics itself was changing in new directions. During the 1920s and 1930s, another revolutionary theory had emerged: quantum mechanics. Quantum mechanics described the behavior of extremely small particles such as electrons, atoms, and photons. It allowed scientists to understand how atoms emitted light, how chemical reactions worked, and how matter behaved at the smallest scales. The theory proved incredibly successful. Experiments confirmed its predictions again and again. Yet Einstein felt uneasy about some of its deeper ideas. Quantum mechanics suggested that certain events in nature were fundamentally unpredictable. Instead of describing exact outcomes, the theory often described probabilities, the chance that a particular event might occur. For many physicists, this probabilistic approach was perfectly acceptable. But Einstein believed that the universe should follow precise and understandable laws. He suspected that quantum mechanics might be incomplete. During conversations with other scientists, he often expressed his doubts with a famous phrase, "God does not play dice with the universe." This sentence did not mean that Einstein rejected quantum mechanics entirely. He understood its mathematical success and its ability to explain experiments. But he believed that deeper laws of nature might still exist beneath the theory. These debates between Einstein and other physicists became some of the most famous scientific discussions of the 20th century. Younger scientists, such as Niels Bohr, argued that quantum mechanics accurately described reality, even if its conclusions seemed strange. Einstein, however, continued searching for a theory that preserved a more deterministic universe. Although he never found the unified theory he hoped for, his questions helped push physics toward deeper investigations of the nature of reality. At the same time, Einstein became increasingly involved in public discussions about global responsibility. The development of atomic weapons had changed the relationship between science and society forever. The bombs dropped on Hiroshima and Nagasaki had demonstrated that scientific discoveries could produce enormous destructive power. Einstein felt a deep sense of responsibility for how scientific knowledge might be used. Although he had not directly worked on the Manhattan Project, the letter he had signed in 1939 had helped alert the United States government to the potential of nuclear weapons. After the war, he devoted much of his public energy to warning about the dangers of nuclear conflict. He believed that humanity had entered a new era. For the first time in history, technology existed that could destroy entire civilizations. Einstein argued that political leaders needed to cooperate internationally to prevent nuclear war. He supported movements that promoted global cooperation and peaceful conflict resolution. One idea he supported was the creation of stronger international organizations capable of managing global security. Einstein believed that if nations continued competing for military dominance, the result could eventually be catastrophic. These warnings made him both respected and controversial. Some people admired his moral courage and willingness to speak openly about global problems. Others believed that scientists should avoid political debates. But Einstein believed that silence was not an option. If scientists understood the dangers created by new technologies, they had a duty to speak honestly about them. During these years, Einstein also welcomed many visitors to Princeton. Students, journalists, political leaders, and scientists traveled from around the world hoping to meet him. Some wanted to discuss physics, others simply wanted to see the famous scientist whose ideas had changed modern science. Einstein usually greeted visitors warmly. Despite his fame, he remained approachable and often spoke with gentle humor. People who met him frequently commented on his thoughtful manner and the calm way he listened before responding. He enjoyed conversations that explored ideas rather than superficial praise. Music also remained an important part of his life. Einstein had loved the violin since childhood. Playing music helped him relax, and sometimes even helped him think about difficult problems. He often said that music allowed him to feel patterns and harmony that were similar to the patterns he searched for in physics. As the years passed, however, his health gradually declined. Even so, Einstein continued working. In his 70s, he still spent many hours studying equations and exploring mathematical ideas connected to his unified theory. Although progress was slow, he rarely lost the curiosity that had guided him since childhood. On April 18, 1955, Albert Einstein died in Princeton at the age of 76. News of his death spread quickly across the world. Scientists, political leaders, and ordinary citizens reflected on the extraordinary life he had lived. Newspapers described him as one of the greatest thinkers in human history. But Einstein himself had always described his life in simpler terms. He once said that he was not especially gifted, only passionately curious. From the moment he first wondered why a compass needle pointed north, his life had been guided by questions. Why does light move the way it does? How does gravity shape the universe? What hidden patterns connect the forces of nature? Those questions led him to ideas that reshaped humanity's understanding of space, time, energy, and the structure of reality itself. Even after his death, Einstein's work continued influencing science. New experiments confirmed predictions from relativity, including gravitational waves and the bending of light by massive objects. Modern technologies, such as GPS satellites, even rely on corrections based on Einstein's theories of space and time. His ideas became part of the foundation of modern physics. The curious child who once stared at a small compass had helped humanity glimpse the deeper structure of the cosmos. And his questions continue inspiring scientists to explore the universe even today. Even after Albert Einstein's death in 1955, his influence did not fade. In many ways, the true impact of his ideas continued growing long after he was gone. Scientists across the world kept studying the theories he had developed, testing them with new experiments, and using them to explore deeper mysteries of the universe. Einstein had changed the way people understood space, time, energy, and gravity. Before his work, the universe had often been imagined as a stable and predictable machine. Space was thought to be fixed and unchanging, and time was believed to flow the same way everywhere. The laws of nature appeared orderly and mechanical, like the gears of a perfectly built clock. Einstein showed that reality was far more dynamic. Space could bend, time could slow down, mass and energy were connected in ways no one had imagined before. These ideas were not only philosophical changes. Over time, they became essential tools for scientists studying the universe. Astronomers began using Einstein's theory of general relativity to understand the motion of stars, galaxies, and massive cosmic structures. The bending of light by gravity, something once considered a strange prediction, became an important method for observing distant objects in space. When light from a faraway galaxy passes near another massive galaxy, the gravitational field bends the light like a lens. This phenomenon, known as gravitational lensing, allows astronomers to see objects that would otherwise remain invisible. It also helps scientists measure the distribution of mass across the universe. Einstein himself had predicted this possibility, though he once believed it might be impossible to observe with the technology of his time. Decades later, powerful telescopes confirmed that the effect was real. Another prediction of Einstein's theory involved the existence of objects so massive that their gravity could trap even light itself. These objects are now known as black holes. In Einstein's time, the idea of a black hole sounded almost unbelievable. Many scientists believed such extreme objects could not exist in reality. They seemed more like strange mathematical solutions than physical objects that could form in the universe. But later observations revealed that black holes are not only real, they may exist in the center of many galaxies. Scientists now believe that enormous black holes sit at the center of galaxies, including our own Milky Way. These objects influence the motion of stars and gas across vast distances. In 2019, astronomers captured the first direct image of a black hole's shadow, using a global network of radio telescopes known as the Event Horizon Telescope. The image showed a glowing ring of light surrounding a dark center, exactly the pattern predicted by Einstein's equations many decades earlier. Another remarkable prediction involved gravitational waves. According to general relativity, massive objects moving through space should create tiny ripples in the fabric of space-time. These ripples would spread outward across the universe at the speed of light, carrying information about the motion of massive objects. For many decades, scientists believed gravitational waves would be far too weak to detect. The signals were expected to be incredibly small, changing the length of objects by less than the width of a single atomic nucleus. But in 2015, researchers working at the LIGO Observatory in the United States announced that they had successfully measured gravitational waves produced by the collision of two black holes. The discovery confirmed another major prediction of Einstein's theory almost 100 years after it had first been proposed. The detection of gravitational waves opened a completely new way of observing the universe. Instead of studying only light from distant objects, scientists could now listen to the vibrations of space-time itself. Beyond astronomy, Einstein's ideas also became part of everyday technology. For example, modern satellite navigation systems rely on extremely precise time measurements. Satellites orbiting the Earth experience slightly different gravitational conditions and speeds compared to clocks on the surface of the planet. According to Einstein's theory of relativity, these differences cause time to pass at slightly different rates. If engineers did not correct for these effects, navigation systems such as GPS would quickly become inaccurate. Positions calculated by satellites would drift several kilometers each day. Thanks to Einstein's theories, scientists understand how to correct these tiny differences in time. As a result, millions of people now rely on technology based on relativity every day, without realizing it. Einstein's work also influenced generations of scientists. Many physicists who made important discoveries in the 20th century were inspired by his approach to science. He believed that imagination and curiosity were just as important as technical skill. Einstein often said that asking the right question was more valuable than simply calculating answers. This mindset encouraged scientists to think boldly about nature. Instead of accepting existing theories as final truths, they learned to question assumptions and explore new possibilities. Einstein also believed strongly in the power of thought experiments. Rather than relying only on laboratory equipment, he imagined situations that revealed hidden contradictions in existing theories. By asking simple questions, such as what it would be like to travel alongside a beam of light, he uncovered ideas that reshaped physics. This approach became an important tool in modern science. Yet Einstein's legacy was not limited to science alone. He also became a symbol of intellectual curiosity and creative thinking. His image, with wild hair and thoughtful eyes, became one of the most recognizable representations of a scientific mind. Teachers used his story to inspire students. Writers and filmmakers used his ideas to explore the mysteries of time and space. Even people who never studied physics came to associate Einstein's name with genius and imagination. But Einstein himself often rejected the idea that he was extraordinary. He insisted that his achievements came from persistent curiosity rather than natural brilliance. He once explained it in simple words: "I have no special talent. I am only passionately curious." This attitude remains one of the most powerful lessons of his life. Einstein's discoveries changed the structure of modern physics, but his approach to thinking may be just as important. He showed that simple questions, pursued with patience and imagination, can lead to revolutionary insights. From the mysterious behavior of light to the bending of space-time, Einstein revealed a universe far more complex and beautiful than anyone had previously imagined. And although science continues advancing beyond his theories, the foundations he created still guide modern research. More than half a century after his death, Einstein's ideas continue shaping how humanity understands the cosmos. The curious child who once stared at a small compass had left behind a legacy that continues inspiring scientists, students, and dreamers to explore the universe and ask new questions about the nature of reality. When people think about Albert Einstein today, they often imagine the symbol of a genius. His wild hair, thoughtful expression, and famous equation have become part of popular culture. Posters, textbooks, documentaries, and films often show the same image: the scientist who changed the way humanity understands the universe. But behind that legendary image was a real person with a complicated and deeply human life. Einstein never thought of himself as a celebrity. In fact, he often felt uncomfortable with the attention that surrounded him after his theories became famous. Fame followed him wherever he traveled, yet he preferred quiet thinking and simple conversations to public admiration. Friends who knew him well often described him as gentle, thoughtful, and sometimes absent-minded. He could spend long periods lost in thought, quietly working through ideas in his mind. During conversations, he sometimes paused for several seconds before answering, as if his thoughts were exploring several possibilities at once. At times, he forgot ordinary things. He might misplace his keys, forget an appointment, or leave letters unanswered for weeks. People sometimes laughed about these habits, but those who knew him understood the reason. Einstein's mind was almost always focused on deeper questions. Even during ordinary moments, his thoughts often drifted toward physics. Music played an important role in his life. Einstein loved the violin and had played it since childhood. His mother had encouraged him to study music when he was young, and over the years the violin became one of his favorite companions. He often said that music helped him think. When he struggled with a difficult scientific problem, he sometimes stopped working and began playing the violin instead. The rhythm and harmony of music seemed to relax his mind and allow ideas to move more freely. After some time, he would return to his desk with a clearer perspective. Friends sometimes joined him for informal evenings of music. These gatherings were not grand concerts, but small moments of creativity shared between friends. They revealed a different side of Einstein, not the famous physicist, but a man who enjoyed art, laughter, and quiet companionship. Einstein also had a strong sense of humor. Despite the seriousness of his scientific work, he often made playful comments about science and life. When journalists asked him difficult questions about relativity, he sometimes responded with jokes that gently reminded people that science should not be surrounded by mystery or fear. On one occasion, someone asked him to explain relativity in simple words. Einstein smiled and said that when a person sits with someone they love, an hour feels like a minute. But when they sit on a hot stove, a minute feels like an hour. Although the explanation was humorous rather than scientific, it helped people understand that time could feel different depending on circumstances. Einstein understood that the public often exaggerated the image of genius. Many people believed that scientific discovery required extraordinary intelligence, available only to a few individuals. Einstein disagreed with this idea. He believed that creativity in science came from curiosity, patience, and imagination. He often encouraged young people to remain curious about the world around them. According to Einstein, the most important skill in science was not memory or calculation, but the ability to ask questions. Children naturally ask many questions. Why is the sky blue? Why do objects fall? Why do stars shine? Einstein believed that this natural curiosity was the starting point of all scientific discovery. Unfortunately, he also believed that traditional education sometimes discouraged curiosity. Schools often focused on memorizing facts rather than exploring ideas. Students were expected to repeat information instead of questioning it. Einstein remembered his own frustration with rigid school systems when he was young. Because of this experience, he often advised teachers to encourage imagination and independent thinking in their students. Another important part of Einstein's personality was his strong belief in intellectual freedom. He believed that ideas should be shared openly and discussed without fear. Science, in his view, depended on honesty, criticism, and cooperation between researchers. When political systems tried to control scientific thought, Einstein strongly opposed such restrictions. His experiences during the rise of the Nazi government in Germany reinforced this belief. Many brilliant scientists were forced to leave their universities simply because of their religion or political opinions. Einstein believed that scientific progress required an environment where ideas could move freely across borders. For this reason, he strongly supported international cooperation among scientists. Even during times of political conflict, he encouraged researchers to continue sharing knowledge and working together. Einstein also had a philosophical side. He often thought deeply about the relationship between science, religion, and human understanding. Although he did not follow traditional religious beliefs, he frequently spoke about a sense of wonder toward the structure of the universe. For Einstein, the laws of nature revealed a kind of harmony and order that inspired deep respect. He once said that the most beautiful experience a person can have is the sense of mystery. Science, in his view, was not only about solving problems. It was also about appreciating the beauty of the universe. This perspective influenced many readers who encountered his essays and public lectures. Einstein believed that scientific curiosity could inspire a deeper connection with the natural world. His life, however, was not without personal struggles. Like many people, he experienced difficulties in relationships and moments of disappointment. Fame sometimes brought pressure and misunderstanding. Yet through all these experiences, Einstein continued returning to the same source of inspiration that had guided him since childhood. Curiosity, the simple desire to understand how the universe works. Einstein never claimed to possess extraordinary gifts. Instead, he often described himself as someone who simply refused to stop asking questions. He believed that curiosity, imagination, and persistence could lead anyone toward deeper understanding. This idea remains one of the most powerful lessons from his life. The world remembers Einstein as one of the greatest scientists in history. But perhaps his most important message was not hidden inside complicated equations. It was something much simpler. Never lose the ability to wonder. Never stop asking questions. And never stop exploring the mysteries of the universe. Albert Einstein's life was filled with remarkable discoveries, global recognition, and a lasting influence on science. His ideas transformed how humanity understands the universe. Yet if we look closely at his story, one simple theme appears again and again: curiosity. From the beginning, Einstein was not trying to become famous. He was not trying to impress others with his intelligence. Instead, he was driven by a quiet fascination with the world around him. As a small child, he once received a simple object from his father, a small compass. The needle inside the compass always pointed in the same direction. No matter how he turned the device, the needle slowly moved back toward the north. For many children, this might have been a moment of brief amusement. For Einstein, it became something much deeper. He later remembered that moment as one of the most powerful experiences of his childhood. The compass showed him that invisible forces existed in the world. Something he could not see or touch was guiding the motion of the needle. This idea fascinated him. It suggested that hidden rules governed the universe. From that moment forward, Einstein began thinking about the invisible structure of reality. As he grew older, his curiosity expanded into more complicated questions. Why does light behave the way it does? How does gravity influence the motion of planets? Is time the same everywhere in the universe? These questions may seem abstract, but they opened the door to revolutionary discoveries. Einstein's theory of special relativity revealed that time and space are not fixed or absolute. Instead, they depend on motion. Two observers moving at different speeds may measure time differently. A clock moving very fast can run more slowly than one at rest. Distances can appear shorter for objects traveling close to the speed of light. These ideas were difficult to accept at first because they challenged centuries of scientific thinking. Yet experiments eventually confirmed Einstein's predictions. Later, Einstein developed his theory of general relativity. This theory transformed the understanding of gravity. Before Einstein, gravity had been described as a force pulling objects toward each other. Isaac Newton's laws explained how this force behaved, but they did not describe its deeper origin. Einstein proposed something entirely different. He suggested that mass and energy bend the fabric of space and time. Planets orbit the sun not because they are pulled by a mysterious force, but because they follow the curved paths created by the sun's enormous mass. This idea changed astronomy forever. Scientists began using Einstein's equations to study phenomena that had never been fully understood before. Black holes, gravitational waves, the expansion of the universe. All of these discoveries are connected to the ideas Einstein introduced. Black holes, for example, are regions of space where gravity becomes so strong that nothing, not even light, can escape. Although Einstein's equations predicted their existence, he himself was unsure whether such objects could really exist in nature. Decades later, astronomers confirmed that black holes are real and may exist in the centers of many galaxies. In 2015, scientists detected gravitational waves for the first time. These waves are tiny ripples in the fabric of space-time created by violent cosmic events such as the collision of black holes. The discovery confirmed another prediction Einstein had made almost a century earlier. Beyond astronomy, Einstein's work also influenced many technologies used in everyday life. For example, modern navigation systems rely on extremely accurate clocks placed on satellites orbiting the Earth. Because these satellites move quickly and experience weaker gravity than objects on the surface of the planet. Time passes slightly differently for them. Einstein's theory of relativity explains these differences. Without correcting for them, navigation systems such as GPS would become inaccurate within hours. In this way, Einstein's ideas have quietly become part of daily life. But Einstein's influence was not limited to science and technology. He also became a symbol of curiosity and intellectual freedom. Throughout his life, he encouraged people to think independently and question accepted ideas. Einstein believed that imagination was one of the most powerful tools in science. He often used thought experiments to explore ideas. Instead of building complex machines, he imagined unusual situations in his mind. What would happen if someone traveled at the speed of light? How would time behave near a massive star? These mental experiments helped him identify contradictions in existing theories and search for deeper explanations. Einstein also believed that scientific discovery depended on persistence. He once said that he was not especially talented, but simply stayed with problems longer than most people. While others might abandon a difficult question, Einstein continued thinking about it until a new insight appeared. This patience allowed him to discover patterns that others had overlooked. Yet Einstein never believed that science existed separate from society. He understood that scientific discoveries could influence the world in powerful ways. The development of nuclear weapons during the Second World War deeply troubled him. Although he had helped warn the United States government about the potential danger of atomic research in Nazi Germany, he later became a strong advocate for nuclear disarmament. Einstein believed that humanity had entered a new era. For the first time in history, scientific knowledge had created the possibility of destroying entire civilizations. Because of this, he argued that wisdom must grow alongside scientific power. Knowledge alone was not enough. Humanity also needed responsibility and compassion. In his later years, Einstein often spoke about the importance of cooperation between nations. He believed that science should bring people together, rather than divide them. The laws of nature belong to all humanity. No single nation owns them. This belief reflected Einstein's deep sense of global responsibility. Today, decades after his death, Einstein's influence remains powerful. Scientists continue using his theories to study the universe. Astronomers explore black holes and gravitational waves predicted by relativity. Physicists search for deeper theories that might connect relativity with quantum mechanics. Engineers design technologies that rely on principles Einstein helped reveal. Students around the world learn about his discoveries in classrooms. But perhaps the most important part of Einstein's legacy is not a single equation or scientific theory. It is the spirit of curiosity that guided his life. The willingness to ask simple questions, the courage to challenge ideas that seem obvious, the patience to search for answers even when the path forward is uncertain. Einstein once said that the important thing is not to stop questioning. Curiosity, he believed, has its own reason for existing. That quiet curiosity, the same curiosity that began with a small compass in the hands of a child, ultimately helped humanity see the universe in a completely new way. And in doing so, Albert Einstein changed not only science, but the way we understand reality itself. Characters. 11,082. Imagine a quiet boy sitting alone near a window. Outside, the world moves, as it always has. People hurry through the streets. Horses pull carts along dusty roads. Factories work day and night. Everything seems ordinary, predictable, and familiar. For centuries, people believed they already understood how the universe worked. Time moved forward at the same pace for everyone. Space was fixed and unchanging. Light simply traveled through the air, like any other wave. But that quiet boy would grow up to prove that almost everything humanity believed about the universe was incomplete. He would show that time is not the same everywhere, that space itself can bend and stretch, that energy and matter are deeply connected in ways no one had imagined before. His name was Albert Einstein. Today, his name has become a symbol of genius. When people talk about intelligence, they often mention Einstein as the ultimate example. His wild hair and thoughtful face have become one of the most recognizable images in modern history. But the truth is far more surprising. As a child, Albert Einstein did not look like someone destined for greatness. In fact, many people around him believed the opposite. Some teachers thought he would never achieve anything special. Others complained that he asked too many strange questions. He was quiet, slow to speak, and often lost in his own thoughts. Yet inside his mind, something unusual was happening. While other children accepted the world as it appeared, Einstein constantly wondered about the hidden rules behind everything. He wanted to understand the invisible forces that shaped reality. And those questions would slowly lead him toward discoveries that changed science forever. To understand how this happened, we must go back to the beginning of his life. Albert Einstein was born on March 14, 1879, in the small German city of Ulm. At that time, Germany was part of a rapidly changing Europe. New inventions were transforming daily life. Railroads connected distant cities. Electric lights were beginning to replace candles and oil lamps. Factories were growing larger, and technology was moving forward faster than ever before. But Ulm itself remained quiet and traditional. It was not a center of science or industry. It was a modest town with narrow streets, churches, and small businesses where families lived simple lives. Albert's parents were ordinary people trying to build a stable future. His father, Hermann Einstein, worked as an engineer and businessman involved in electrical equipment. Electricity was still a new and mysterious force during those years. Many people did not yet understand how powerful it would become. But Hermann believed that electrical technology would play an important role in the future. Albert's mother, Pauline Einstein, brought a different influence into the family. She loved music deeply and believed that culture and education were essential parts of life. She encouraged creativity, patience, and discipline. One of the first things she introduced to young Albert was the violin. At first, the boy was not very enthusiastic about practicing. Like many children, he preferred playing and exploring rather than sitting still with an instrument. But over time, something changed. Music began to calm his restless thoughts. As he grew older, playing the violin became one of the ways he relaxed and organized his ideas. Years later, when he faced difficult scientific problems, Einstein often turned to music. He would play for long periods, letting his mind wander. Sometimes the answers he searched for appeared while he was listening to the rhythm and harmony of the notes. Yet during his earliest years, Albert developed in a way that puzzled the adults around him. He was unusually quiet. Other children spoke quickly and easily, but Albert often paused for a long time before answering questions. Sometimes he repeated sentences softly to himself before saying them aloud. Family members worried that something might be wrong. A few relatives even feared he might never become a strong communicator. But while his speech developed slowly, his mind was constantly observing the world around him. He noticed details that others ignored. He thought deeply about simple objects and everyday events. And one small moment during his childhood would leave a powerful impression on him. When Albert was about 5 years old, his father showed him a pocket compass. It was a simple instrument, a small needle inside a glass case that always turned in the same direction. no matter how the compass was moved or rotated, the needle slowly returned to point north. To adults, this was just a useful tool for navigation. But to Albert, it seemed mysterious. He could not see what was moving the needle. There were no wires, no visible forces, no hands guiding it. Yet something invisible was clearly controlling the direction of that tiny piece of metal. That moment filled him with deep curiosity. If an invisible force could control the compass needle, what other hidden forces might exist in the universe? This question stayed with him for the rest of his life. It was the beginning of a lifelong fascination with the unseen structure of reality. Long before he understood mathematics or physics, Einstein already sensed that the universe contained invisible rules waiting to be discovered. Soon after, the Einstein family moved to Munich, a much larger city than Ulm. Munich offered new opportunities for Hermann's electrical business and exposed young Albert to a more complex and busy environment. The city was growing quickly. New industries appeared every year. Electricity was beginning to power machines and lighting systems. Europe was entering a period of scientific and technological excitement. But the education system Albert encountered there was very strict. German schools in the late 19th century emphasized discipline and obedience. Students were expected to memorize information and repeat it exactly. Teachers demanded silence and order in the classroom. For many children, this system worked well. For Albert Einstein, it created a problem. He did not enjoy memorizing facts without understanding them. He wanted explanations. He wanted to explore ideas and ask questions. When something did not make sense, he felt compelled to investigate further. Unfortunately, curiosity was not always welcomed in the classroom. Some teachers interpreted his questions as challenges to their authority. They preferred students who followed instructions without debate. Einstein's habit of thinking differently sometimes created tension with those responsible for teaching him. Yet despite these difficulties, his curiosity continued to grow stronger. Even when school felt frustrating, the young boy never stopped asking questions about the world. Why did magnets attract metal? How did light travel through space? Why did the stars remain in the sky instead of falling to Earth? These simple questions slowly formed the foundation of a mind that would one day reshape science. But at that moment, Albert Einstein was still just a quiet child in Munich. No one could yet imagine that the boy who wondered about compasses and invisible forces would eventually reveal some of the deepest secrets of the universe. When Albert Einstein was still a young boy in Munich, life around him followed a predictable rhythm. The streets filled each morning with workers heading to factories, shopkeepers opening their doors, and students walking toward their classrooms. Germany in the late 19th century valued order, discipline, and structure. Schools reflected this philosophy very clearly. Children sat in neat rows of wooden desks. Lessons were delivered in a strict and organized manner. Teachers expected students to listen quietly, memorize information, and repeat it exactly when asked. For many students, this system worked well enough. They followed the instructions, completed their exercises, and moved forward year after year. Albert, however, experienced school very differently. He was not disruptive, and he rarely caused trouble. But he did something teachers found uncomfortable. He asked questions that did not fit neatly into the lesson. If a teacher explained a rule, Albert often wanted to know why that rule existed. If a mathematical formula was presented, He wanted to understand how someone had discovered it in the first place. Instead of simply accepting facts, he tried to see the deeper logic behind them. To some teachers, this behavior appeared stubborn. They believed a student should first learn the rules and only later begin questioning them. Albert's habit of thinking independently sometimes made him seem difficult. One teacher reportedly told him that his presence in class undermined the respect students were supposed to show their instructors. But Einstein was not trying to challenge authority. He simply could not stop his mind from exploring ideas. Outside the classroom, he spent long periods thinking quietly about everyday phenomena. He might watch the movement of light across a wall in the afternoon sun. He might observe the patterns formed by ripples in water. He might examine simple mechanical devices and wonder why they worked the way they did. These quiet observations slowly trained his mind to notice patterns and relationships that others overlooked. His parents watched this curiosity with mixed feelings. On the one hand, they were proud that their son showed interest in learning. On the other hand, they worried about his future. School success in Germany required discipline and obedience. A student who questioned everything might struggle to fit within the system. Fortunately, Albert encountered an important influence during these years. A young medical student named Max Talmud often visited the Einstein household for dinner. At that time, it was common for families to invite students to meals as a way of offering hospitality and intellectual conversation. Max quickly noticed the curiosity in young Albert and began bringing him books. These books were not ordinary children's stories. They were introductions to mathematics, science, and philosophy. Albert devoured them with intense concentration. One book in particular made a deep impression on him. It explained basic ideas of geometry. Instead of memorizing facts, geometry showed how logical reasoning could lead step by step toward a clear conclusion. For Einstein, this was a revelation. The proofs in geometry felt certain and reliable. Each step followed naturally from the previous one. The ideas did not depend on authority or tradition. They depended on logic. He later described this experience as discovering a kind of inner harmony in mathematics. Once he understood how a proof worked, the conclusion felt unavoidable. The truth revealed itself through reasoning alone. This discovery gave him great joy. It showed him that knowledge could be built through careful thought rather than simple memorization. Around the same time, he developed a growing fascination with mathematics itself. Numbers behaved according to rules that seemed precise and elegant. Equations could describe relationships between objects and events. And unlike many subjects in school, mathematics allowed him to explore ideas independently. He could experiment with problems on his own and verify whether his reasoning was correct. This independence suited him perfectly. By the age of 12, he was teaching himself advanced mathematical concepts that were normally introduced years later in school. His textbooks often became too simple for him, and he moved beyond them by studying additional material he found through friends or libraries. Meanwhile, his formal education continued in the rigid German system. The teachers emphasized discipline and obedience, especially in the gymnasium, the secondary school designed to prepare students for university study. Students spent long hours memorizing Latin, Greek history, and classical literature. Albert respected knowledge, but he disliked the method used to teach it. The environment felt overly strict. Creativity and imagination were rarely encouraged. Students were expected to follow instructions without debate. For a mind as curious as Einstein's, this atmosphere felt restrictive. He later compared the experience to military training. Teachers behaved like commanding officers, and students were expected to follow orders. Despite this frustration, Einstein still performed reasonably well in certain subjects. Mathematics and physics came naturally to him. But his relationship with authority figures remained difficult. Some teachers saw potential in him. Others saw only a student who refused to follow the expected path. Outside school, however, his intellectual world continued to expand. He read widely whenever he had the chance. Scientific essays, philosophical discussions, and mathematical explanations all captured his attention. The more he learned, the more he realized how many unanswered questions existed. Why did light travel at a particular speed? What exactly was electricity? Could the laws of nature be described using simple principles? These questions began forming the foundation of the ideas that would later define his career. Yet during these early years, Albert Einstein was still simply a thoughtful teenager growing up in Munich. He walked the same streets as other students, attended the same classes, and lived a quiet life with his family. No one looking at him then would have predicted the dramatic influence he would eventually have on science. Even Einstein himself could not yet imagine the discoveries waiting ahead. But one thing was already clear. The boy who had once stared in wonder at a small compass was slowly developing a powerful habit of questioning reality itself. And those questions were only beginning. By the time Albert Einstein reached his teenage years, the gap between his way of thinking and the rigid structure of school had grown even wider. The gymnasium in Munich where he studied was known for discipline and tradition. The goal of the institution was simple: to prepare students for university through strict intellectual training. Lessons followed a precise routine. Students arrived early in the morning and spent long hours memorizing classical texts, studying Latin grammar, and repeating information exactly as teachers presented it. The system had been designed to produce orderly, obedient scholars. For some students, this environment provided stability and clear expectations. For Einstein, it felt suffocating. He did not dislike learning. In fact, he loved learning more than most students. But he disliked learning without understanding. When teachers asked students to repeat information by memory, Einstein felt frustrated. He wanted to know the deeper reasons behind every rule, every equation, every statement. If something did not make sense to him, he could not simply accept it. This habit created tension in the classroom. Some teachers interpreted his questions as disrespect. Others believed he lacked discipline. One instructor reportedly told him that nothing good would ever come of him because he refused to follow instructions properly. Einstein later remembered these moments clearly. The problem was not intelligence. The problem was that the system expected conformity, while his mind constantly searched for freedom. Despite these conflicts, he continued to excel in mathematics. Numbers behaved differently from the rigid rules of school. Mathematical ideas followed logical patterns that he could explore independently. If he started with a problem, he could experiment with different approaches until he found a solution that made sense. This process felt like solving puzzles. And Einstein loved puzzles. He began studying geometry more seriously during these years. The certainty of mathematical proof fascinated him. If one step followed logically from another, the result became undeniable. Unlike school authority, which demanded belief, mathematics offered understanding. But Einstein's intellectual curiosity was not limited to numbers. He also became interested in physics, particularly the mysterious nature of light. Light surrounded everything. It allowed people to see the world, yet its true nature remained unclear. Scientists of the time debated whether light behaved like waves moving through space or tiny particles traveling at enormous speed. The question was far from settled. Einstein often imagined strange scenarios involving light. One thought in particular stayed with him. What would happen if someone could travel alongside a beam of light? If a person moved at exactly the same speed as light, what would they see? Would the light appear frozen in space? Or would it continue moving forward? These were not ordinary questions for a teenager to ask, but Einstein's mind often drifted toward such imaginative experiments. He did not need expensive equipment or complex laboratories. His laboratory was his imagination. And in that quiet mental space, he began exploring ideas that would later become the foundation of modern physics. Meanwhile, life in Munich continued to change. Albert's father, Hermann Einstein, had been trying to build a successful electrical business. But competition in the growing industry was intense. Larger companies were beginning to dominate the market. Eventually, the family business began to struggle. Financial pressure forced the Einstein family to make a difficult decision. Hermann and Pauline moved to northern Italy, where new opportunities in electrical engineering seemed promising. Albert, however, remained behind in Munich. His parents believed it was important for him to complete his education before joining them. So he stayed with relatives and continued attending the gymnasium. For the first time in his life, he lived away from his parents. The separation was not easy. Without his family nearby, the strict environment of school felt even more oppressive. Einstein felt increasingly isolated. The more he thought about the rigid rules of the gymnasium, the more convinced he became that the system was not designed for someone like him. Eventually, the situation reached a breaking point. At the age of 15, Einstein made a bold decision. He left school. Officially, he obtained a medical note from a doctor, stating that the environment of the gymnasium was harming his mental health. With this document, he withdrew from the institution and traveled to Italy to reunite with his family. For many teenagers, leaving school would have created serious problems. Education in Germany followed a clear path. Students completed the gymnasium, entered university, and pursued professional careers. Without finishing school, Einstein seemed to be stepping outside that system entirely. But he felt relief rather than fear. For the first time in years, he felt free to think. Italy offered a very different atmosphere from Germany. The pace of life felt more relaxed. Conversations were lively and expressive. The strict discipline that dominated German classrooms seemed far away. Einstein spent long hours walking through the streets of Milan and Pavia, observing architecture, reading books, and thinking about science. During this period, he wrote a small essay describing his thoughts about the nature of electricity and magnetic fields. Even at 16, his ideas showed a deep curiosity about how invisible forces shaped the physical world. However, he also understood that his future still required formal education. Without a diploma, entering university would be difficult. So he began searching for another path. Eventually, he discovered a school in Switzerland that offered a different educational philosophy. the Swiss Federal Polytechnic in Zurich trained students for careers in engineering and science. Unlike the rigid German system, the atmosphere in Switzerland was known to be more open and independent. Einstein decided to apply. The entrance examination, however, proved challenging. Although he performed extremely well in mathematics and physics, his scores in other subjects were not strong enough for immediate admission. Most students would have seen this as failure. But the director of the Polytechnic noticed something unusual in Einstein's results. His scientific ability was extraordinary. Instead of rejecting him completely, the school offered a suggestion. If Einstein completed an additional year of study at a Swiss preparatory school, he could apply again. Einstein accepted the opportunity. Soon he would move to Switzerland, where a new chapter of his life would begin. A chapter that would bring him closer to the discoveries that would change science forever. But at that moment, he was still simply a young man, searching for the right place, where his restless curiosity could finally grow. When Albert Einstein left Germany and traveled to Switzerland, he was entering a very different world. The strict discipline of the German school system was behind him, and ahead lay a country known for independence, tolerance, and intellectual freedom. Switzerland, in the late 19th century, had a reputation for openness. Students from many countries came there to study because the universities encouraged discussion and independent thinking. For someone like Einstein, whose curiosity often clashed with rigid authority, this environment would prove extremely important. But before he could enter the Swiss Federal Polytechnic in Zurich, he had to complete one more step. Because he had not finished the German gymnasium, the Polytechnic required him to attend a preparatory school in the town of Aarau. This school would help him strengthen the subjects where he had struggled and prepare him for the entrance examination. Einstein arrived in Aarau in 1895. At first, he was uncertain about what to expect. His previous experiences with school had been frustrating. He worried that this new institution might follow the same strict methods that had caused so many problems in Munich. But almost immediately he realized that Aarau was different. The teachers encouraged students to think for themselves. Instead of simply memorizing information, students were asked to explain ideas, debate solutions, and explore problems creatively. For Einstein, this change felt almost revolutionary. For the first time, school felt like a place where curiosity was welcome. He lived with a local family during his time in Aarau, the family of Professor Jost Winteler. The Winteler household was warm and lively, filled with conversation about literature, philosophy, and politics. Einstein quickly formed a close relationship with the family, especially with the professor's children. These discussions expanded his intellectual world. Instead of focusing only on formal lessons, Einstein now spent evenings talking about ideas, reading widely, and thinking about science in new ways. The relaxed atmosphere allowed his imagination to develop without the pressure he had experienced in Germany. During this year in Aarau, one of his most famous thought experiments began to take shape. Einstein started wondering again about the strange nature of light. He imagined what it would be like to travel through space at the same speed as a beam of light. If someone could move alongside light itself, what would they observe? Would the light appear frozen? Would time behave differently? These questions might sound abstract, but for Einstein, they were very real. He pictured the situation in detail, as if it were happening around him. He imagined standing beside a beam of light moving through space and watching how it behaved. These mental experiments became a habit. Einstein discovered that by imagining physical situations carefully, he could explore scientific problems without needing complex equipment. His imagination became a kind of laboratory where ideas could be tested. This unusual method of thinking would later become one of the defining features of his scientific work. By the end of the school year in Aarau, Einstein had gained confidence in his abilities again. His teachers recognized his talent, especially in mathematics and physics. Encouraged by their support, he prepared to take the entrance examination for the Swiss Federal Polytechnic once more. This time, the result was different. In 1896, Albert Einstein was admitted to the Polytechnic in Zurich. The institution, which later became known as ETH Zurich, was one of the most respected scientific schools in Europe. It trained engineers, mathematicians, and teachers who would go on to shape modern technology and science. Einstein enrolled in the program that prepared students to become teachers of mathematics and physics. At 17 years old, he had finally found a place where his interests matched the structure of education. Life in Zurich brought new experiences. The city itself was vibrant and international. Students from different countries filled the classrooms and lecture halls. Conversations about science, politics, and philosophy continued late into the evening in cafes and student apartments. Einstein quickly became part of this intellectual atmosphere. He made several important friendships during his early years at the Polytechnic. One of the most significant was with a fellow student named Marcel Grossmann. Grossmann was organized, disciplined, and excellent at taking detailed lecture notes. Einstein, by contrast, often skipped lectures that he considered dull or repetitive. Instead of attending every class, he preferred studying the material on his own. He spent long hours reading scientific works by some of the greatest physicists of the 19th century. Scientists like James Clerk Maxwell had developed powerful theories about electricity, magnetism, and light. Maxwell's equations suggested that light was a form of electromagnetic wave traveling through space. These ideas fascinated Einstein. He studied them carefully, trying to understand every detail. Yet even as he admired Maxwell's work, he sensed that some important questions remained unanswered. How exactly did light move through space? And why did its speed appear constant, no matter how the observer moved? At the time, most physicists believed that light traveled through an invisible substance called the ether. This mysterious medium was thought to fill all of space, providing something for light waves to move through. But experiments designed to detect the motion of Earth through this ether were producing confusing results. The more Einstein studied these problems, the more curious he became. While other students focused mainly on passing exams, Einstein spent much of his time thinking about these deeper questions. He discussed them with friends, scribbled notes in small notebooks, and continued performing mental experiments about light and motion. Yet despite his intellectual passion, his academic record at the Polytechnic was not perfect. His independent style sometimes created problems with professors who expected strict attendance and discipline. Some instructors admired his intelligence, but others found his behavior frustrating. Einstein often relied on the lecture notes taken by his friend Marcel Grossmann when preparing for exams. Even so, his understanding of physics continued to grow. The years in Zurich shaped him in important ways. They gave him freedom to explore ideas, introduced him to new friends and collaborators, and strengthened his confidence as a thinker. But when Einstein finally graduated in 1900, he faced a new challenge: finding a job. Despite his talent, his reputation among some professors made it difficult for him to secure an academic position. Several instructors hesitated to recommend him for assistantships. The young graduate who dreamed of exploring the secrets of the universe suddenly found himself struggling to find work. And the next stage of his life would begin in a place far removed from famous laboratories and universities. It would begin in a quiet office where inventions were reviewed and patents were approved. A place that would unexpectedly become the birthplace of some of the greatest ideas in the history of science. When Albert Einstein graduated from the Swiss Federal Polytechnic in Zurich in the year 1900, he expected that the next step of his life would naturally lead him toward an academic career. Many students who completed their studies at the Polytechnic continued working with their professors as assistants. These positions allowed young scientists to continue their research while gaining experience in teaching. Einstein believed he would follow the same path. But reality turned out to be very different. During his years at the Polytechnic, Einstein had developed a reputation among some of his professors. They respected his intelligence, but they also noticed his independence. He often skipped lectures that he believed were unnecessary. Instead of attending every class, he preferred studying important ideas on his own. This habit made him appear unreliable to some instructors. When the time came for professors to recommend students for assistant positions, Einstein discovered that several of them were reluctant to support him. Without these recommendations, finding work within the university system became extremely difficult. For the first time in his life, Einstein faced real uncertainty about his future. He had completed his education, but no academic job was waiting for him. The months after graduation were frustrating. Einstein sent letters to universities and research institutes across Europe, hoping that someone might offer him a position. Again and again, the replies returned with polite rejections. Sometimes there was no response at all. Meanwhile, life continued moving forward. Einstein needed to earn money. Without a steady income, he could not support himself, and he certainly could not pursue the scientific questions that filled his mind. Eventually, he accepted temporary work as a tutor, helping students prepare for examinations in mathematics and physics. These jobs provided small amounts of income, but they were unstable and unpredictable. Students came and went, and tutoring could not guarantee a long-term career. During this uncertain period, Einstein's personal life also began to change. Among his classmates at the Polytechnic had been a young woman named Mileva Maric. She was one of the few women studying physics at the time and had a strong interest in scientific ideas. Einstein and Mileva often discussed physics together, sharing thoughts about difficult problems and exchanging books. Their friendship gradually deepened into a romantic relationship. They spent many evenings walking through the streets of Zurich, talking about science, philosophy, and their hopes for the future. Both believed that their lives would eventually revolve around research and discovery. But for the moment, Einstein's lack of stable employment made everything uncertain. Despite these difficulties, his curiosity never disappeared. In fact, During this time of struggle, Einstein continued thinking about some of the most puzzling questions in physics. He carried notebooks filled with ideas, sketches of equations, and thoughts about the behavior of light. Often he discussed these ideas with close friends. One of them was Marcel Grossmann, the organized and reliable classmate who had helped him during his studies. Grossmann came from a well-connected family, and he sympathized with Einstein's situation. It was Grossmann who eventually suggested a possible solution. His father knew someone working at the Swiss Patent Office in the city of Bern. The office was responsible for reviewing new inventions submitted by engineers and inventors. Each application had to be examined carefully to determine whether the invention was truly original and whether it could receive legal protection. The job required someone capable of understanding technical descriptions and mechanical ideas. Grossmann believed Einstein might be well suited for this work. At first, the idea seemed strange. Einstein had dreamed of becoming a scientist and teacher, not a government clerk reviewing patents. But after months of unsuccessful job searches, the opportunity suddenly appeared attractive. In 1902, after an interview process, Einstein received an offer. He was appointed as a technical expert at the Swiss Patent Office in Bern. The position was modest but stable. His job involved examining descriptions of electrical devices, communication systems, and mechanical inventions. Each day he read detailed explanations submitted by inventors, hoping to secure patents for their creations. Einstein analyzed these proposals carefully, checking whether the ideas were new and whether they worked according to the principles described. At first glance, the work might seem routine and repetitive, but the environment at the patent office offered something unexpectedly valuable. It provided Einstein with time to think. Unlike university researchers who faced constant pressure to publish papers and impress senior professors, Einstein worked in a quiet office with regular hours. Once he completed his assigned tasks, he could use his free time to explore his own ideas. And he used that freedom wisely. In the evenings, after finishing his work, Einstein often walked home through the streets of Bern, thinking deeply about physics. The questions that had fascinated him since his youth still occupied his thoughts. What exactly was light? Why did experiments show that its speed remained constant? And what would happen if the basic assumptions about time and space were not entirely correct? Gradually, he formed a small group of friends who enjoyed discussing these problems. They jokingly called their informal gathering the Olympia Academy. The name sounded grand, but in reality it was simply a circle of curious minds meeting in apartments and cafes. Together they read books on science and philosophy, debating ideas late into the night. These conversations strengthened Einstein's confidence. Although he was not working at a university, he still felt connected to the world of ideas. And the quiet environment of the patent office allowed him to focus deeply on problems that other scientists had not yet solved. In many ways, this unexpected job created the perfect conditions for creativity. While the scientific world continued its research in universities and laboratories, Einstein was quietly developing ideas in his spare time, ideas that would soon change physics forever. But no one outside his small circle of friends had any reason to suspect what was about to happen. The young clerk reviewing patent applications in Bern appeared to be living an ordinary life. Yet within his mind, revolutionary ideas were slowly taking shape. And within only a few years, those ideas would begin to transform our understanding of the universe. When Albert Einstein began working at the Swiss Patent Office in Bern, his daily life settled into a simple and predictable routine. Each morning, he walked through the quiet streets of the city to the office building where he spent several hours examining patent applications. Inventors from across Europe submitted detailed descriptions of their ideas. Some proposed new electrical machines. Others described improved communication systems or mechanical devices designed to solve practical problems. Einstein's job was to read these documents carefully and decide whether the inventions were truly original. To do this, he needed to understand how each device worked. He studied diagrams, analyzed explanations, and imagined how the machines would function in real life. If an idea seemed unclear, he had to mentally reconstruct the invention step by step until its operation became obvious. This work required careful reasoning and strong imagination. And although the job itself was not glamorous, it helped Einstein sharpen an important skill. He learned to visualize complex systems in his mind. Instead of building machines with his hands, he built them mentally. He imagined gears turning, signals traveling through wires, and energy flowing through circuits. Over time, this practice strengthened his ability to picture physical processes with remarkable clarity. When the workday ended, Einstein's real interests began. He returned to his small apartment and often continued thinking about the scientific questions that had fascinated him for years. The quiet evenings gave him space to explore ideas without interruption. Around this time, he also married Mileva Maric. The two had known each other since their days at the Polytechnic in Zurich. In 1903, they officially married and began building a modest life together in Bern. Their apartment was small, their finances limited, but they shared a deep interest in intellectual discussion. Meanwhile, Einstein continued meeting with his small group of friends in what they jokingly called the Olympia Academy. Despite the grand name, the group was informal. A few young men gathered regularly to read books, discuss philosophy, and debate scientific ideas. They studied works by thinkers such as David Hume, Ernst Mach, and Henri Poincaré. These philosophers questioned many traditional assumptions about knowledge, perception, and the nature of reality. Their writings encouraged careful thinking about what could truly be known through observation and reasoning. Einstein found these discussions stimulating. They helped him think more clearly about the foundations of physics. At the beginning of the 20th century, physics was already a successful science. Many scientists believed that the basic laws of nature had largely been discovered. Classical mechanics, developed by Isaac Newton centuries earlier, described the motion of objects with remarkable accuracy. Electromagnetic theory, developed by James Clerk Maxwell, explained the behavior of electricity, magnetism, and light. Yet certain puzzles remained. One of the most confusing involved the speed of light. According to Maxwell's equations, light always traveled at the same speed in empty space. This speed appeared to be constant, independent of how the observer moved. But this idea created a problem. In everyday experience, speeds combine in simple ways. If someone throws a ball while standing on a moving train, the speed of the ball relative to the ground becomes the speed of the throw plus the speed of the train. Scientists expected light to behave similarly, but experiments suggested something strange. No matter how fast the observer moved, measurements always gave the same speed for light. This result seemed impossible within the framework of classical physics. Many scientists tried to explain the problem using the idea of the ether, an invisible medium filling all space. Light waves were believed to travel through this mysterious substance. But experiments designed to detect Earth's motion through the ether failed to find any evidence of it. The puzzle remained unsolved. Einstein returned to the thought experiment that had fascinated him since his youth. What would happen if someone moved alongside a beam of light? According to classical ideas, a person traveling at the same speed as light should see the wave frozen in space. But Maxwell's equations did not allow such a situation. Light could not simply stop moving. This contradiction suggested that something deeper was wrong with the traditional assumptions about motion, space, or time. For years, Einstein carried this problem in his mind. He considered many possibilities. Perhaps the measurements were wrong. Perhaps the theory of light was incomplete. Or perhaps the deeper concepts of time and space themselves required rethinking. Gradually, a bold idea began forming. What if the laws of physics were the same for all observers moving at constant speed? And what if the speed of light truly remained constant for everyone, no matter how they moved? If these two principles were accepted, then some familiar ideas would have to change. Time might not flow identically for all observers. Distances might not remain fixed. Events that seemed simultaneous to one observer might appear to occur at different moments for another. These conclusions sounded strange, even impossible. Yet the mathematics suggested they might be correct. Einstein continued exploring the consequences of this idea during his evenings in Bern. Page after page of calculations filled his notebooks. All the while, his life outwardly remained ordinary. Each morning, he returned to the patent office. He reviewed inventions, wrote reports, and followed the routines of a government employee. Few people around him suspected that the quiet clerk was developing ideas that would soon reshape the foundations of physics. But in 1905, something remarkable would happen. Within a single year, Einstein would publish several scientific papers that transformed the understanding of light, motion, and energy. Later generations would call this extraordinary period his miracle year. And it would turn the unknown patent clerk from Bern into one of the most important scientists in history. In the year 1905, Albert Einstein was still living a quiet and almost invisible life. Nothing about his daily routine suggested that he was about to change the way humanity understood the universe. Each morning, he walked through the calm streets of Bern and arrived at the Swiss Patent Office. The building itself was modest, and the work inside followed a steady rhythm. Inventors from across Europe submitted descriptions of machines, electrical systems, and mechanical devices. Einstein's responsibility was to study these documents carefully and determine whether the inventions were truly new. To the outside world, his life looked ordinary. He read reports, he analyzed technical diagrams, he wrote official summaries, then he went home. But while Einstein performed his duties with precision, his mind was constantly occupied by deeper questions. Even while reading patent applications, part of his attention drifted toward problems that had fascinated him since his youth. The problem of light. For decades, scientists had been trying to understand exactly what light was. Experiments showed that it behaved like a wave, spreading through space in patterns similar to ripples on water. The mathematical equations developed by James Clerk Maxwell described this behavior beautifully. But there was a strange contradiction hidden inside those equations. They predicted that light always traveled at the same speed, no matter who measured it, no matter how fast the observer moved. This result did not match ordinary experience. In everyday life, speeds always combine. If someone throws a ball forward while riding a moving train, the speed of the ball relative to the ground becomes the speed of the throw plus the speed of the train. But light refused to follow this rule. Experiments showed that its speed remained constant in every situation. Many scientists tried to explain the mystery using the idea of an invisible substance called the ether. According to this theory, light waves traveled through the ether the way sound waves travel through air. But experiments designed to detect this ether repeatedly failed. No matter how carefully scientists measured, they could not find any sign that Earth was moving through such a medium. Einstein could not stop thinking about this contradiction. He returned to a question that had first entered his mind as a teenager. What would happen if someone could move alongside a beam of light? If a person could travel at exactly the same speed as light, what would they see? Would the light wave appear frozen? Would it stop moving? But Maxwell's equations did not allow such a situation. According to those equations, light could never stand still. That meant something was wrong. Either the equations were incomplete, or the basic ideas about space and time were mistaken. Einstein began exploring a radical possibility. What if the speed of light was truly constant for everyone, not just approximately constant, absolutely constant? And what if the laws of physics were exactly the same for every observer who moved at a steady speed? At first glance, these ideas seemed simple, but when Einstein followed them to their logical conclusion, the results were shocking. If the speed of light cannot change, then time itself must behave differently than people believed. Two observers moving relative to one another will not measure time in the same way. Clocks can run at different speeds depending on their motion. The faster an object moves, the more slowly time passes for it. This idea was completely unexpected. For centuries, people had believed that time flowed at the same rate everywhere in the universe. Einstein showed that this was not true. Time could stretch. It could slow down. It depended on motion. Distance also behaved differently. Objects moving at extremely high speeds would appear shorter in the direction of their movement. Even the concept of two events happening at the same moment could change depending on the observer. Something that seemed simultaneous for one person might occur at different times for another. Space and time, which people had always treated as separate and unchanging, were suddenly connected in a new and surprising way. Einstein called this new understanding special relativity. But his discoveries during 1905 did not stop there. In another paper written that same year, Einstein proposed a bold explanation for a puzzling phenomenon involving light and metal surfaces. Scientists had observed that when light struck certain metals, it could release tiny particles called electrons. But the effect only occurred when the light had a high enough frequency. Increasing the brightness of the light did not produce the effect unless the frequency was sufficient. This behavior confused many researchers. Einstein suggested that light sometimes behaves as if it consists of tiny packets of energy. Instead of being purely a continuous wave, light could also appear in small individual units. These packets would later be called photons. The idea was revolutionary. It helped explain the strange experimental results and opened the door to a completely new branch of physics that would later be known as quantum theory. And in yet another paper that same year, Einstein explored the relationship between mass and energy. He realized that matter itself contained enormous amounts of energy. Even a small amount of mass could be converted into a vast quantity of energy. This insight led to one of the most famous equations ever written. Energy equals mass multiplied by the speed of light squared. The equation was short, but its meaning was profound. It revealed that mass and energy were simply different forms of the same physical reality. Remarkably, Einstein produced all of these ideas within a single year. 4 scientific papers, each addressing a major mystery in physics, each introducing concepts that would transform scientific understanding. Later historians would call 1905 Einstein's miracle year. Yet at the time, almost no one realized what had happened. Einstein remained a clerk at the patent office. He continued reviewing inventions, writing reports, and walking home through the quiet streets of Bern. But slowly, scientists across Europe began reading his papers. At first they were puzzled, then they were intrigued, and eventually they understood that something extraordinary had occurred. A young man working far from the great universities had quietly rewritten the rules of physics, and the world of science would never be the same again. At first, the scientific world did not react dramatically to Einstein's papers from 1905. They were published in respected journals, but revolutionary ideas rarely spread overnight. Many scientists were busy with their own research, and Einstein was still an unknown name without a university position or famous mentor supporting him. For a while, his papers simply existed quietly in the scientific literature. But slowly, the situation began to change. A few physicists started reading his work more carefully. When they examined the arguments line by line, they realized that Einstein was not just adjusting existing theories. He was questioning the foundations of physics itself. Among the first major scientists to recognize the importance of Einstein's work was Max Planck. Planck was already one of the most respected physicists in Europe and a pioneer in the study of energy and radiation. When he studied Einstein's theory of relativity, he quickly understood that something extraordinary had been proposed. Planck began mentioning Einstein's ideas during his lectures in Berlin. This mattered more than Einstein himself could have imagined. When a scientist of Planck's reputation spoke about a new theory, other physicists paid attention. Soon, researchers in different parts of Europe began studying Einstein's papers more seriously. Some attempted to test the predictions mathematically. Others tried to understand the deeper meaning behind the strange conclusions. Many scientists reacted with skepticism. The theory of relativity challenged ideas that had seemed obvious for centuries. Since the time of Isaac Newton, people believed that time flowed at the same rate everywhere in the universe. A second in one place was the same as a second anywhere else. Space was also considered fixed and unchanging. It was the stage on which all physical events occurred. Einstein's theory suggested something completely different. Time could move at different speeds depending on motion. Distances could change. Two observers moving relative to one another might disagree about the length of an object or the order in which events happened. At first, these ideas felt almost impossible to accept. Even experienced physicists struggled to understand them. Some scientists rejected the theory immediately because it seemed too strange. Others simply needed time to study the mathematics carefully. But gradually, the logic of Einstein's work became harder to ignore. The equations were elegant and internally consistent. They also explained several experimental results that had puzzled physicists for years. Step by step, interest in relativity began to grow. Meanwhile, Einstein's personal life remained surprisingly ordinary. He was still working at the Swiss Patent Office in Bern. Every morning, he walked to the same building and spent hours examining patent applications from inventors. His job required concentration and technical understanding, but it had little connection to the revolutionary ideas developing in his mind. To his co-workers, Einstein was simply a thoughtful and somewhat absent-minded colleague. Few people around him realized that his scientific work was beginning to attract international attention. Outside the office, however, letters began arriving. Scientists from other countries wrote to ask questions about his theories. Some asked for clarification of specific equations. Others wanted to discuss the philosophical meaning of relativity. Einstein responded carefully to many of these letters. For the first time, he felt that his ideas were entering the broader scientific conversation. In 1909, 4 years after the miracle year, an important opportunity appeared. Einstein received an offer to become a lecturer at the University of Zurich. The position allowed him to leave the patent office and finally devote his life entirely to science. Although the salary was not large, the change meant freedom. He could now spend his days teaching students and developing new ideas, rather than reviewing technical documents. For Einstein, this moment marked the true beginning of his academic career. Students who attended his lectures often noticed that he was different from many traditional professors. He did not behave like a strict authority figure standing above his students. Instead, he explained ideas in a relaxed and thoughtful way. Sometimes he paused in the middle of a lecture to reconsider an explanation if he believed it could be clearer. If a student asked an interesting question, Einstein welcomed the interruption. Curiosity had guided his own life, and he encouraged it in others. Despite his growing reputation, Einstein remained deeply focused on unanswered problems in physics. Special relativity had transformed the understanding of motion, time, and space. But it applied only to objects moving at constant speeds. Gravity remained outside the theory. For centuries, Newton's law of gravity had described how objects attract each other. Planets orbit the sun because of gravity. Objects fall toward Earth because of it. Yet Newton's theory did not explain why gravity existed. It described how the force worked, but not its deeper origin. Einstein believed a more fundamental explanation must exist. He began wondering whether gravity might not be a force in the traditional sense at all. Perhaps gravity was related to the structure of space and time themselves. To imagine this idea, Einstein often used a simple comparison. Picture a stretched sheet of fabric. If a heavy ball is placed on the fabric, the surface bends under the weight. Now imagine rolling a smaller ball across the sheet. Instead of moving in a straight line, it curves toward the heavier object. Something similar might happen in the universe. Massive objects like stars and planets could bend the structure of space and time around them. Other objects would move along curved paths because the space they traveled through was no longer flat. developing a mathematical theory to describe this idea proved extremely difficult. For nearly 10 years, Einstein worked on the problem. His notebooks filled with calculations as he searched for equations capable of describing how space and time might curve. At times, he doubted whether the solution even existed. But in 1915, he finally found the answer. The result became known as the general theory of relativity. According to this theory, gravity is not simply a force pulling objects together. Instead, mass and energy change the geometry of space and time itself. Planets orbit stars because they are moving through curved space. Light passing near a massive object should bend slightly as it travels. Time itself should pass more slowly in strong gravitational fields. These predictions sounded extraordinary. Yet Einstein was confident that the mathematics was correct. What remained was to test the theory through observation. That opportunity arrived a few years later during a rare solar eclipse. Astronomers used the event to measure how starlight bent as it passed near the sun. When the results were announced in 1919, they matched Einstein's predictions. Suddenly, newspapers around the world began reporting on the strange new theory of gravity and the scientist who had proposed it. Almost overnight, Albert Einstein became famous. The quiet physicist who had once worked alone in a patent office was now recognized as one of the greatest minds of his generation. And the world had just begun to understand how profoundly his ideas would change science. In November of 1919, something extraordinary happened. For the first time in history, a scientific discovery became front-page news across the entire world. Newspapers in London printed dramatic headlines. One announced, "Revolution in Science." Another declared, "Newton's ideas overturned." For centuries, Isaac Newton's explanation of gravity had been one of the strongest foundations of science. His laws described the motion of planets and falling objects with remarkable accuracy. Generations of scientists built their work upon those ideas. Yet now newspapers were telling readers that a new theory had changed everything. At the center of this story stood a quiet physicist with thoughtful eyes and unusual hair, Albert Einstein. Only a few years earlier, he had been an unknown clerk, working in a patent office in the Swiss city of Bern. Very few people outside the scientific community had heard his name. Now, almost overnight, his ideas were being discussed across continents. The event that triggered this sudden fame was a rare astronomical phenomenon, a total solar eclipse. During such an eclipse, the moon moves directly between the Earth and the sun, blocking the sunlight and darkening the sky for a short period of time. For a few brief minutes, stars that are normally hidden by daylight become visible around the darkened disk of the sun. This rare moment created the perfect opportunity to test one of Einstein's bold predictions. According to his general theory of relativity, gravity does not simply pull objects together like an invisible force. Instead, massive objects such as stars and planets bend the fabric of space and time around them. If this idea was correct, then light traveling close to a massive object like the sun should not move in a perfectly straight line. Instead, its path should curve slightly as it passed through the warped space surrounding the sun. In other words, gravity could bend light. This meant that during a solar eclipse, the positions of stars appearing near the sun should seem slightly shifted from where they normally appeared in the night sky. The change would be extremely small, so small that measuring it required very careful observation. But if astronomers could detect this tiny shift, it would provide powerful evidence supporting Einstein's theory. In 1919, 2 scientific expeditions were organized to test the prediction. One group of astronomers traveled to the island of Principe, located off the west coast of Africa. Another group traveled to Sobral in northern Brazil. The scientists carried telescopes, cameras, and measuring equipment designed to photograph the stars surrounding the darkened sun during the eclipse. Their task was difficult. Clouds could easily block the sky and ruin the observations. The instruments had to be carefully aligned and protected from heat and vibration. Even the smallest error could distort the measurements. The teams waited anxiously for the day of the eclipse. When the moment finally arrived, the sky darkened, and the sun disappeared behind the moon. For a few precious minutes, the astronomers captured photographs of the stars surrounding the black circle of the eclipsed sun. Later, after the expeditions returned home, the scientists compared these photographs with earlier images of the same stars taken when the sun was far away from that region of the sky. The comparison revealed something remarkable. The stars had shifted. Their light had bent slightly while passing near the sun, and the amount of bending matched the prediction made by Einstein's equations. When the results were announced later that year, the scientific world reacted with excitement. Einstein's theory had successfully predicted a phenomenon that no earlier theory could explain. But the reaction did not remain limited to scientists. Newspapers quickly reported the story to the general public. The idea that a new theory had replaced the traditional view of gravity captured the imagination of readers everywhere. Journalists wrote about the strange new vision of the universe in which space could bend and time could slow down. And they wrote about the quiet scientist who had proposed these ideas. Albert Einstein suddenly became famous. Reporters asked for interviews. Photographers wanted portraits. Universities invited him to give lectures in cities across Europe. Crowds gathered wherever he appeared. For Einstein, the attention felt strange and unexpected. For years he had worked quietly, thinking about problems that very few people understood. Now his name appeared in newspapers around the world, and strangers recognized his face. People often asked him to explain relativity in simple terms. Einstein sometimes answered with humor. On one occasion he joked that if his theory had been proven wrong, Germany would say he was Swiss, Switzerland would say he was Jewish, and France would say he was German. But since the theory had been confirmed, everyone wanted to claim him as their own. Despite the fame, Einstein himself remained modest. He did not see himself as a celebrity. His real interest remained the search for deeper understanding of nature. Fame did not change the way he worked. He still spent long hours thinking quietly, exploring new questions about the universe. At the same time, the world around him was entering a difficult period. The First World War had ended only a short time earlier. Much of Europe had been devastated by the conflict. Cities were damaged, economies were struggling, and millions of families were mourning the loss of loved ones. Einstein watched these developments with deep concern. Unlike many intellectuals of his time, he openly spoke against war and nationalism. He believed that science belonged to all humanity, and that knowledge should connect people rather than divide them. This position made him controversial in some political circles. But Einstein believed strongly that scientists had a responsibility to think beyond national borders. Meanwhile, his scientific influence continued growing. Researchers across Europe and America began studying relativity in detail. Universities introduced courses dedicated to Einstein's theories. Young physicists traveled great distances, hoping to meet the man whose ideas had transformed modern physics. Yet despite the growing attention, Einstein remained driven by the same curiosity that had guided him since childhood. The boy who once stared at a small compass in wonder was still asking questions, still imagining strange possibilities, still searching for deeper patterns hidden within the universe. Fame had arrived suddenly, but the journey of discovery that had begun in his childhood was far from finished.